my two topics are very related, so I'm going to put mine two together. That's all right with everyone. That's how I thought it would be. So my topic is called neural hyperscanning, and I'll share my screen in a minute. So let me introduce myself. So I'm a clinical psychologist, but I do neuroscience research, and I work at Columbia Teachers College in the clinical psych program. And I work a lot with, I teach about meditation and neuroscience in the program. And so my presentation, and I'll share screen. So it's called neural hyperscanning, and it's kind of a new frontier. So the idea is that we measure brain waves, and we measure different recordings across multiple devices. And doing that is hyperscanning. So hyperscanning involves simultaneous recording hemodynamic or neuroelectric measurements of brain activity in two or more interacting individuals, recording multiple subjects' brain activity simultaneously as they interact with each other. Hemodynamic would be for MRI because it's measuring oxygen in the blood. Neuroelectric would be more for EEG. So neural hyperscanning is a technique used in neuroscience research, and it measures. So there's different ways the neural hyperscanning is measured. Some are through social interactions, communication, and cooperation. There's also game theory. So there's games of competition and cooperation. And the different game theory paradigms. Also, we look at the connection between people's brains. So just kind of in summary, I'd say over about 30, 40 years, there's been 126 studies and using EEG, MRI, fNIRS, which is near infrared measurement, functional MRIs, and the studies have broken down to cognition, decision-making, and synchronization. So for the focus of one of the reviews is EEG, I just kind of wanted to give kind of a breakdown of EEG in case it seems like we're multidisciplinary, and so maybe some are not familiar with what EEG is. So basically, the EEG measures surface electrical energy on the brain using something called basically an EEG cap, and there's channels. So the channels are these little nodes on the head, and depending on the device, there can be a low density, so maybe just a very few number of these little channels, or a high density. So these caps in the photo are high density caps. The EEG is measured in frequency. So the lowest frequency is a delta, which would be 0 to 4 hertz. And in this case, they're defining as 0.5 to 3 hertz, but it can be 0 to 4. Actually, the individual research papers do define the bands. Ultimately, the band, there's a large spectrum of frequencies, but the band it tends to be defined, but it falls generally within these parameters. Theta is 4 to 7 hertz. Alpha is 8 to 12 hertz, and the alpha can be divided into alpha 1 and alpha 2, which would be a lower alpha, 8 to 10 or 10 to 12. There's a beta, 13 to 13 hertz, and a gamma rhythm, which is a high frequency brainwave. The conditions are related to different states of mind, states of being. You're generally, your day-to-day, your waking brainwave would be a beta brainwave, so the 13 to 30 hertz. The high end would be considered gamma. Your alpha is kind of a relaxed state, and then your theta is a deeply kind of the REM one. So right when you're falling asleep, you start to get the dream images. You're in the theta brainwave, and so yeah, these are your normal. Your alpha is kind of the relaxed focus. So moving forward, you have these paradigms for neural hyperscanning. And it's a way we can measure connectivity that we've never even thought about before. So there's different tasks you can do. One task would be music, another task would be mimicry, social mimicry. There's aside from experimental hyperscanning, there's ecological hyperscanning. So in a classroom setting or in a concert hall. And the implication is we can measure connectivity like we've never measured before. So here's one example of a classroom setting, and this is an ecological setting. So they use the cap called a motive. It's like a 14 channel cap. So those channels are the little nodes, the little sensor nodes. And the students, when they tuned into each other and the teacher, there was more synchrony, and there was synchrony in the alpha band, so that 7 to 12 hertz. And the synchrony was predictive of the shared attention in the group. So the more alpha, the alpha synchrony was correlated with the group focus. Here's a research paper that some of my lab members worked on. Basically just kind of an overview. And the point of our hyperscanning was so we can conduct a hyperscanning study, our hyperscanning review. So we looked at 433 articles, and we broke down the different types of hyperscanning. And it was broken down to cooperation and competition. So these are game theory paradigm sort of tasks. One example would be the ultimatum game. And this is there's a dictator game, and they're like these games people play where there's decision making, and you can measure the cooperation or competition within the game. There was interaction tasks, so speech, naturalistic interaction. There was coordination and imitation, where people would hold up their hands and coordinate different tasks, or hold their hands to each other and mimic each other. Music was an equals 6, so participants were asked to play an instrument or played an instrument together. And there was a mind-body, only one mind-body practice, where there was a meditation interaction between the meditation leader and person receiving the kind of guided meditation. Generally, the finding was alpha. There was an alpha, the largest synchrony was in the alpha range. So there's alpha coherence. So alpha, remember, was a 7 to 12 hertz. And a second finding was theta was actually more related to emotionally laden tasks. So when there was emotion involved in the interaction, there was more likely to be a theta synchronization. Here's examples of all the types of connectivity metrics through synchronization. So you can have coherence, you can have phrase locking, you can have Kraskov mutual information, and partial directed coherence, and then just basic correlations. So it gets a little complicated when you look for connectivity. Future directions. Where does hyperscanning take us? So I just published a paper on the future of neurosociology. So how can we now look at sociology on a kind of broader meta-neurological level? And we haven't really had this ability before. So, say you go to a baseball game and measure every single person there, or a basketball game, or different institutional settings, lectures, classrooms, and that was the only classroom study to date. These are things we were never able to do before, because these devices are extremely expensive. And now there's been an advent of open source EEG devices, which have made everything a lot less expensive. And we can measure we can measure everything on a much larger level. There's also kind of a deeper theory that the basis for this is possibly a form of entanglement or quantum entanglement. Actually, this year the Nobel Prize was just won for quantum entanglement, and quantum entanglement is the photons being connected at a distance, or particles or groups of particles being connected at a distance and acting in synchrony. In this case, the mind is a group of ions, photons, particles, and these particles can be connected at a distance. And this is, one kind of theoretical basis for the connection. Distal connectivity, we excluded 16 studies on distal connectivity, but there was coherence at a distance, coherence at in shielded rooms at a distance. And those were really fascinating studies. We didn't include them in the review. Maybe we'll do a separate review on these distal connectivity studies, where a yoking mechanism could connect people. And the first study for this was in 1996. It was based on the Einstein-Rosen-Polatsky paradox. And it was the first distal hyperscanning study, and then that kind of theorized quantum entanglement. And the Einstein-Rosen-Polatsky paradox was a paper proposed in 1935, and it was the first paper ever to hypothesize the notion of quantum entanglement, which is now experimentally validated. And for my own work would be to do, and it hasn't been done really very much, is to do meditation and contemplative hyperscanning, where we use meditation and mind-body practices as a yoking mechanism for the neural hyperscanning. Actually, I don't know how long I've been talking. So I'll just stop, and we can just kind of just address some issues, or you can ask me some questions if you want.
Well, if you could really get that linking going, we wouldn't need Zoom anymore. It's just telepathy.
Yeah. So then we're all together, and the
Right.
question, to what degree are we connected through some kind of form of entanglement or coherence? So then I lead meditation as well. So I have a meditation in my class, and then I had meditation in Zoom. And the question is, what will be the difference, in between these two forms of meditation? There is a feeling of connectivity. There is a positive effect. And someone did a review on meditation during COVID, and they found that there were similar effects: reduction in depression, anxiety, etc. But there is one difference, is that there's completely different stimuli in all of our environments. So we're in different rooms, there's different smells, there's different sounds, there's different haptic stimulation, and that's the main difference. So there is kind of a lack of coherence. The interesting part about it is that actually the group setting can be more powerful in person, because you can look at the principles of a laser. How does a laser work? So a laser is highly coherent. Actually, all the particles are in synchrony with each other. And all the particles are not necessarily in sync when we're in these kind of environments. However, they can be. We can all be very much in sync in these settings. So that's the next level, is to do Zoom-based hyperscanning studies, and then do in-person hyperscanning studies and compare the difference. So new frontier, new field. Hopefully you'll hear more about hyperscanning in the future. I think it very much applies to clinical settings. So woman was working with ADHD medication psychology. And with patient therapist interactions, we can look at hyperscanning and group settings, and it'll be the new frontier, I think, for this neural brain research. So that's it.